There's just a ton of excitement to see this really come to fruition, be launched, and then there's going to be a whole nother level of excitement when we start to see the data flow in and we get to really analyze the data and study and say, whoa, a black hole just formed right there and we just observed the signature of it. Let's start making this light curve in this spectra and really studying it now. Abe Falcone, I'm an associate professor here in the Astronomy and Astrophysics department at Penn State University. We're really excited because we've been working for 5 years now to build our own satellite observatory mission here in this lab. This is the High Energy Astrophysics and Detector and Instrumentation Lab at Penn State. And we have built BlackCAT. The BlackCAT CubeSat is a black hole coated aperture telescope. This telescope is going to look in X-rays. So X-ray wavelengths, much higher energy. These are photons still, just like optical light. But these higher energy photons will come in, hit the surface of our telescope here. Some of them will get blocked and some of them won't get blocked because they'll go through little holes that are here. This is a gold surface that can help block the X-rays. And the ones that don't get blocked will go down to our X-ray detectors on the back focal plane of the telescope. And we'll be able to piece together from this, from the shadow that the blocked parts cast, we'll be able to piece together what the X-ray night sky looks like. And we'll take really rapid images over and over and over and over again and see when big bursts go off of X-ray radiation. So that gets to our main science goal. We're trying to find gamma ray bursts that are particularly shifted down into the X-ray regime instead of being peaked at the gamma ray regime but peaked in X-rays. These particular gamma ray bursts are ones that are going to come from very far away at the edges of the universe. So those gamma ray bursts had to come from stars. And when those stars end their life, it's in a cataclysmic, beautiful way where they collapse down to a black hole. If they're spinning fast enough, that black hole's spinning and a jet spews out lots of radiation. And if that jet is pointed right at us, we see it here in our telescope. BlackCAT will be orbiting around the Earth, and it'll keep doing that. It'll have an orbit about every 90 minutes. It'll go around the Earth, and its solar panels will be looking out towards the sun the whole time, and it'll rotate around, and this opening, this area here, will look for those gamma ray bursts all that time while it just keeps going around the Earth every 90 minutes. It's important for everyone to understand where they came from. You know, we're studying the first stars, where they formed, how they formed. Then as the cosmic cycling happens, more stars form later on in the universe's history, and the metals that we all see and live with today form. We're basically trying to understand where the universe as we see it has come from. And part of that process of understanding those fundamentals is understanding the first stars that formed in the universe. So I feel as though it's part of the grand human endeavor to understand where we are, what our place is in the universe, and part of that is understanding how the universe works. This is also developing that technology so that we can build those next generation great observatories. The James Webb Space Telescope that many people know of, the Hubble Space Telescope. There are X-ray and gamma ray versions of these too. For instance, Chandra is up there right now, and Chandra is getting a little old, and we need a new big great X-ray observatory. And we're developing the technology that can be that big new great observatory of the future. But we have 4 detectors, just like BlackCAT's 4 detectors, inside that vacuum chamber. And we have an X-ray source in there, mimicking X-ray sources out in the sky. Are Laurel and Abby out there? Why don't you call them, unless you guys want to go out there and just...
I was going to get some of the data and stuff. Am I going to be in your way? From the other side?
Small enough that you can't see them with that camera, but they're about 40 microns across each of the pixels there. So this is a spacecraft. There were each one of them had a few different pictures, and some of them had the actual real satellite there.
It looks it's cool to have a 3D model of it.
Abe, I have all the fully deployed pictures. Do you have those?
I sent them a couple.
Jelajahi cara baru mendapatkan informasi. Download MetroTV Extend sekarang.